Hallo, it's dumplet here. Here's an item on number theory. Find all natural numbers n such that 2 raised to 2 raised to n plus 5 is prime. Credits to the Art of Problem Solving community for this item. As usual, pause this video if you'd like to give this item a try. But if you're done, let us dive into the solution. Alright, so we just want to make sure that this thing is prime. Now, well, it's not obviously factorable or anything, so let's just try to substitute some values of n, and maybe we're going to see something interesting from there, right? I mean, in a lot of these questions, we typically try to do small cases for now. Okay, so if I have n equals 1, okay, that's pretty doable. 2 raised to 2 raised to 2 raised to 1, that's 2 raised to 2, plus 5, so that's just 4 plus 5, that's 9. N equals 2, 2 raised to 2 raised to 2, that's 2 raised to 4 plus 5, so 16 plus 5, that's 21. Right, next, 2 raised to, n equals 3, that becomes 2 raised to 2 raised to 3, 2 raised to 8 plus 5, no, 2 raised to 8, that's 256, that's going to be 261. Right, there's actually something interesting here, but let me just keep going. N equals 4, that's going to be 2 raised to 16 plus 5. Okay, now for some of you guys, 2 raised to 16 is 65,536. And, okay, we just have to add 5 to it, so 65541. And I've mentioned something interesting about these three, and I realized they're all multiples of 3. 3 times 3, 3 times 7, and 3 times 70, 3 times 87, like this. Alright, so that's something interesting. Now, I'm not sure if this is divisible by 3, I'm not sure that if this is 3 times anything, but I can tell you it is divisible by 3, because if I were to check the sum of its digits, 6 plus 5 plus 5 plus 4 plus 1, we use the divisibility rule for 3, that's going to add up to 21, and yes, it is divisible by 3. So, I mean, I've been only doing the first 4 terms, but I have a claim that this is always divisible by 3. Again, it's just a claim, so, but based from my trial and error here, or just substituting the small cases, it seems to be true. Okay, so let's try to see if this is divisible by 3. Now, obviously, the easiest thing to do is going to be taking mod 3. Alright, now, taking mod 3 is actually very nice because, well, the 2 here and the 5, I'm going to write the 2 as specifically -1, and then raising it to the 2 raised to n. And then the 5, that just becomes 2 under mod 3. So, alright. Oh, whoops. Let me just write this as congruence. So they're congruent. The given is congruent to -1 raised to 2 raised to n plus 2 mod 3. Now, we could just use the fact that 2 raised to n is always even for natural numbers n. So we're just going to have here, so -1 raised to a certain even number plus 2 under mod 3. And I know this is congruent to -1 raised to an even number, that's just 1. So 1 plus 2, that's equal to 3, and that's indeed 0 mod 3, right? So our claim is actually true, so let me just remove the question mark here. So now it's always divisible by 3, okay? It's always divisible by 3. So the last thing we have to check, can this thing be 3? But then again, from what we observed a while ago, well, n equals 1 gives 9 already, and we can easily see that as n grows bigger, this thing is going to grow. So this is strictly increasing. That's what I meant to say. So it doesn't reach 3 at all. So it's divisible by 3, but it's not equal to 3. So this is going to be expressed as 3 times something, where k is not equal to 1. So it's a multiple of 3. Therefore, it's never prime for any natural number n. So to answer the question, there are no natural numbers n that make 2 raised to 2 raised to n plus 5, this thing over here, prime. And this will be our final answer. Hopefully you guys learned something new from this video, and I'll see you in the next one. Bye bye!